Hello everyone. Welcome back to our 100-day System Verilog learning challenge. And today we are going to learn about the task and function which was there in System Verilog. See, your task and function is the most important concept in your entire System Verilog. We will cover the entire thing which was there in task and function, and I will wait you like you will never find such content on entire YouTube like in comprehensive way. So just watch till the end, and we have also included some numerical example, or you can say some practical example, so that it will clear your understanding about the task and function. So now let's start the video. First of all, this is my introduction. My name is Kittu Patel, and if you have any query, so you can contact me on this number, or you can also send your query in my email. Okay, so just connect with me if you have any query. Now let's start the task and function. So let's see the introduction. So first of all, let me give you the introduction why we are using task and function. Now suppose you have one code and you have to write a same piece of code again and again. So rather than writing it again and again, you just have to create one function. Okay. Now you have to call this function whenever you want this function inside your code. So that's the role of your function and task. So there are basic difference between function and task which will be learn. So these are the intention to use your task and function. So whenever you want your code, like you have to use your code multiple times. So rather than writing the entire code multiple times, you just create one function or task, and then you can call their function and task to adapt their functionality. Okay. So this is the main role of your function and task. So it will increase your code reusability. So like you have increased your code reusability, and it will also making your complex design and verification environment easier to read, and it is also easy to debug and maintain. Okay. So think of them like a modular building block where you can perform specific procedures. Okay. Now see, while they share the goal of code modularity, which we have discussed, and they have distinct characteristics that make each suitable for different scenarios. Okay. Now let's understand this difference is crucial for effective system Verilog programming. I have already mentioned that why are we using function and task, because we use code modularity or code reusability. So that's why we are using function and task. Now let's deep dive into task. So see, task is nothing but a procedural block. Okay, we have learned about the procedural and continuous block. So task is nothing but a procedural block that can execute over multiple simulation time unit. Like whenever you want your task to be executed, so you can able to do. Okay. Now they are ideal for modeling sequences of events. Like you will learn events in our later video, but you can keep this in mind. Event generally add some time delay. Okay. Now stimulus generation, or you can say in complex verification routine that involve waiting of clock. So you can keep this in mind. Just a simple thing, your task allow a timing delays. Like if you want some time delay, so you can able to do in task which was not allowed in function. So that's the intention of the task mainly. Okay. Now see, task argument direction. So there are majorly four kinds of argument. First is input, second is output, third is in-out, and fourth is ref. Let's understand each one in detail. So see, your input port is nothing but you are passing some input by using input port. So here changes within the task are not visible outside. Okay, because this is the default direction if none is specified. So if you haven't specified any direction in your task argument, so it will default consider the input. Okay. Now the output. Here the value is copied out from the task and to calling the variable at the end of the task execution. Okay. So here the value is copied from the task and you can get at the end of the execution. Now in out. So it allows bidirectional data transfer, like you are sending something and you are getting something. So this is how your in out will work. Now ref. Ref is a special kind of, you can say system Verilog specific argument which allow you to pass your argument by reference, meaning like you can passing a pointer to the original variable is passed. So suppose you have passed a original variable, so now you have passing one pointer that is pointing to the original variable. So if you are making any change in the like your created variable, so this will reflected in your original variable. So keep this in mind. Now default variable, if you haven't give any direction in your task argument, so it will considered as an input. Okay, so the default direction is input, and once a direction is given like output or in out, so it will subsequently argument in that list to default to the same direction until another direction is explicitly specified. Okay. Now let's see the task execution and control flow. So like whenever your task is called, so it control faces to the task. Okay. So see, whenever your task is being called, so it control passes to the task. So suppose you have one code, okay, so you have one module and here you have one task. So whenever you are calling your task, so it will just go to your task and it will start executing the entire code sequentially inside the task. So your entire statement, or you can say your statement within the task, are executed sequentially. And also keep this in mind, here no need to add begin end block. Okay, it will automatically like execute your statement sequentially. Now your task can contain timing control statement. Okay, so I have already discussed like this all are timing control statement, like you are adding some delay or you are waiting for an event. So this all are timing control constraint which will add some time delays in your task, so which can suspend its own execution. Okay, now a task can call other task or function inside the task. So you are allowed to call another task inside a task, or you can also allowed to call a function inside a task. Now your task control return to the enabling process only after the task has fully completed. Okay, so I hope this will clear to you. And now this means your task enablement time can differ significantly, like from its return time due to its internal delay. Like we are adding some delay, so it will take some time in full execution. Okay. Now return statement. So you can use return to exit a task prematurely before the task end is reached. So suppose you have one task, like you have added one task and now you want to return somewhere between these. Now you don't want to execute this piece of code. So you can use one return statement to get out of the task. Okay. So this is the basic things which you have to learn about the task. Now let's see the static versus automatic task. So there are two types of task. One is static and the another one is automatic. Now let's first see static task. So the task which you are adding inside the module, interface, program or packages, they are by default in static in nature. Okay, so all declared item like your arguments or your local variable are statically allocated. What I mean, it share a common memory location, like they shared a common, or you can say they shared across all concurrent invocation of the same task. Now see, here variables return their value between invocation, like whenever you are invocating their task, so your variable will return their value. Okay, now like suppose if your static task is called concurrently, so all invocation like will operate on the same set of variable. Suppose you have one set variable and you have concurrently executing your task from multiple times, so your all variable will operate at the same time, which lead to an unexpected behavior. Okay, now they are initialized to the default initialization value, that is if 0 for logic or null for object. So if you have an object, so their default value is null. So that's what it want to clear. Now let's see the automatic. So whenever you are writing your task inside the class method or explicitly declared, so it will consider automatic in nature. Okay. Now your all declared items allocated a stack for each task invocation. So suppose in static, like your all invocation shared a common memory location, but here you will get some individual memory for each invocation. So your each concurrent call get its own unique copy of variable. So that tasks are redundant. That means like they can be called recursively or concurrently without interfering with each other local data. Like we have seen in like our static kind, that if you are concurrently invocating your task, so it will lead to some unexpected behavior, but that will not gonna to happen in automatic because they are created its own unique copy for multiple call. Now input and in-out argument are initialized with the value passed from a call at each invocation. Now if you have output argument are initialized to the default value at each invocation. So we have already seen in the static, this happen in static also. So what is the crucial restriction? So see, your automatic task variable cannot be assigned using non-blocking statement. Keep this in mind. So your automatic like task variable, so you can't able to assign your automatic task using non-blocking assignment or procedural continuous assignment. So nor can they be used with monitor or dump words. So you are not allowed to use monitor or dump words when you are writing your task automatic, because they are deallocated when the task is complete. But here our concern was not to deallocate our task. Okay, so that's why they are not used. Now let's deep dive into the function. So see, function is also a procedural block designed for a return a single value. So like our task, your function is also a procedural block which is mainly designed to return a single value and must complete in zero simulation time. Whereas our tasks are taking some delay kind of thing, but your function don't allow or not allowed any kind of delay. Okay, I hope it is clear to you. Now they are perfect for the calculations kind of thing because they are executing at zero simulation time, data transformation or utility routines. Okay. Now let's see the return type. So see, if you don't want to return anything, so you have to just use void. So your void means you are not returning anything. If you want to return something, so you can write your return parameters like whatever you want to return. So its lifetime will remain same as the task. Okay. So your its lifetime is same as the task. Now some rules and restrictions which was there with the functions. Now to ensure that your function will return at zero time execution and also it will return some value. So function have added some restrict rules. Okay. So you don't have to use some time controls because if you are using time control, so your function will not complete at zero simulation time and that restrict and that violate the rule of function. So you are not allowed to use any timing control inside the function. Now not task enabling. So since our task has like a timing delay, so you cannot use or you cannot call your function. So since our task has some time delay, so you are not allowed to call your task inside a function. Okay, because your task has some time delay. Now return value. So see, a single non-void function must return a single value, or you can say like a non-void function. Whenever you are not adding void function, so your non-void function will return a single value, and it is mandatory. So the return value can be specified by like you are assigning to an implicit internal variable that has the same name and the same function itself. Okay. Now using the return statement with some expression. So by using expression, you can also return some value, and by using return statement which will override by some value. So this kind of return you can expect it from the function. Okay. Now let's see the static versus automatic function. So see, whenever you are writing your function inside the module, interface, program or package function, so in that case your function is static. So all internal items are statically allocated and shared across all concurrent invocation. So here your variable can return their value between multiple calls. Now let's see the automatic. So whenever you are invoking your function inside the method or you can say class method, so your default variable, so your default nature of your function is automatic. So your all internal items are dynamically allocated for each invocation, making the function renaturant, which we have seen the meaning of renaturant in task part. Okay. Now this is essential for your recursive function as each recursive call need its own set of variable. So here whenever you call in automatic, so it will get some unique copy. So that make your code more like you can say renaturant. That means you can call concurrently your function. Okay. Now let's see the constant function. So see, constant function is also a very, you can say, important things in function. So here whenever you are defining some constant function, so it will evaluate it at elaboration time. Whenever you learn UVM now, so there are multiple phases in UVM like build phase, connect phase, end of elaboration phase and start simulation phase, then run phase. So these all phases are there in UVM. But here you can see at elaboration time. That means before your simulation start. Okay. So your constant function is specialized type of function designed to be evaluated at elaboration time. So this means the result can be used in context that require constant expressions like your parameter declaration or array. Okay. So array dimensions like there our concern is to make our things constant. So that's why we are using constant function. Now these are some key points about the constant function. So you are not allowed to use output, inout or ref argument. So you are only allowed to use input argument. Okay. Now it must return a value. Your function or you can say your constant function cannot be a void. Now you are not allowed to use any timing control which was there in function also. Now you are not able to access their hierarchical reference. So you cannot access variable outside its own scope. Okay. So you cannot also call non-constant function inside the constant function. Now limited system functions are available. Only system function allowed in constant expressions that are beats, array query function are permitted. system tasks like $display and $monitors are ignored in your constant function. Now let's see the function with background process, that is fork join none. So we will also discuss like fork join none. But for being now, I am giving you some insight about the fork join none. So see, whenever you are writing fork join none, and fork join none will basically an block where you are writing multiple thread being executed parallelly. So whenever you are adding fork join none, so that thread will scheduled for later, and then your execution, or you can say that your pointer will come out of the fork join none block, and it will execute the outside the statement which was there at the real simulation time, and then it will go inside the block and then execute your inside thread statement. Okay, so these are the basic execution of your fork join none. So while you are using function must execute in 0 simulation times. So SystemVerilog allow a specific exception like your fork join none construct within a function. This create like background process that start executing concurrently with rest of the function but continue after the function return. Okay, I have discussed like what is fork join none. So that's behavior your function is following. Now it allowed statement. So your fork join none within a function can contain any statement which is legal within a task. Now its restriction is this is generally allowed only if the thread calling the function is in initial or always procedure, or in the flock, or inside a fork block from one of those. Okay. Now in the context where a side effect is permitted, so this simulation tool will issue an error if their provision are not met. I hope it is clear. Now you can pass your argument by two way. One is pass by value and the another one is pass by reference. So by default you can pass your value is the pass by value. So arguments are copied here into the subroutine local storage. So if your subroutine is automatic, a local value, or you can say that a local copy is written on its stack, and the changes are made to the argument within the subroutine are not visible to the calling construct. Now consideration. So see, you're copying. Now see, you are copying a large data structure can be inefficient in terms of memory and performance. So see, whenever you are changing, so just keep this in mind. So whenever you are changing your local variable, it will not reflected, or your changes will not reflected in the copied variable, or if you are making any change in the copied variable, it will not reflected in the original variable. So you are creating some different copy as compared to the original copy. Okay, so this is the basic intention of pass by value. Now let's see the pass by reference. So I just simplified what is pass by reference. So if you have pass your value as in passed by reference, so if you are like making changes in your copied variable, so it will get reflected in your actual variable. That means here you are not passing the actual copy, just you are passing a reference copy, or you can say the address handling. So your copied, or you can say your pointer will point to that address location. So if you are making any changes in that address location, then it will get reflected in your original variable. Okay, so that's the basic intention of pass by reference. So this is crucial for your performance and also for sharing data. Now this is the these are the some restriction which was there in pass by reference. So you can be only used with automatic task and function. Okay, now argument passed by ref must be equivalent data type. So no implicit casting is allowed here in pass by reference. So only variable class properties and your member of unpacked structure or elements of unpacked array can be passed by reference. No nets or select information are allowed. Now an argument passed by ref cannot be used in the context forbidden for automatic variable, and you can also be cautious with the refer to elements of dynamic array or queues that might be resized or delete in the caller scope. So the reference can become outdated. So you have to keep this in mind, all these points. Now we are going to see some practical examples that will clear your understanding more in detail. So now I have opened my EDA. Here my intention is to not explain this project. My intention is just to get like how your task and function is being different from each other and how you can define it. So see, I have defined my task outside the module, so you are allowed to do that. So I have defined one task which is of automatic type, and I have used output port which is of pulse signal, which is for pulse signal, and input which is delay on, and input which is delay off. Now here I am generating a simple pulse generator. Okay, so initially I have taken my pulse signal as an 0. Now after that I am adding some delay, and this delay, like here hashtag delay on, will come from the our module. Okay, so here delay on we are getting from our module. So that's all. Now after that I am making my pulse signal 1 and I am printing this, and then after that I am getting delay off, which is also I am getting from the module, and then I am like again my pulse goes low. Okay, now here I am ending my task. Now here our pulse generator actual module was. So here you can see I have invoked my task. Here you can see generate pulse I have called. So I have passing my argument my pulse, and then I have passing 50 and 30. So here my pulse was your actual pulse signal, and 50 and 30 was your delay on and delay off. So you can use the same sequence which you have defined. So I have given 50 and 30 as an delay on or delay off, and after 100 time unit again I am invoking my task, and then I am giving some delay on and delay off. Okay, now let's run this code and see the actual output. So now here you can see that our pulse generator class task start at 0, and then after 50 time unit I have given pulse on. You can see that here I have given from the argument. I have given as an argument. Okay, so at 50 time unit our pulse on has been invoked, and at the 80 time unit, because means here I have sent it in 50, and then after 30 means total time 80. So after 80 our pulse off has been executed. Okay, and pulse generation completed 80. Now again we are passing at 180, because here we have considered 100 unit of time delay. So that's why 80 plus 100, that means 80, 180. Okay, so at 180 we are again passing it at 20. So after 180 plus 20, that means 200. So after 200 our pulse on has been executed, and after 60 time units, which means 260, pulse off has been executed. So this is the basic execution of our task. So see here we are adding some delays, so that will allowed by the task, but in function we are not allowed to use any kind of delay. So now let's see the functions. Okay, now here you can see I have written one function for calculating our parity. Our intention was not to here understand the logic and all. I am just giving you the insight of function. So here I have considered one input which is of byte data type, and byte data type is of 8-bit, which we have already discussed in our data type video. So here we have considered one input. Okay, now initially I am giving my parity to 0, and then after I am XORing our each bit to 8 time. Okay, which is of, because our byte is of 8-bit, that's why I am repeating my loop 8 time. Okay, and then I am returning my parity bit. Okay, so from here I am invoking my functions. You can see here, like you can see here, from here I am invoking my function. I am calling my parity function like calculate even parity, and I am giving test byte 1. So here test byte 1 is already being defined and initialized. So I am sending 1010. So here even number of ones they have been calculated and been executed. Now let's run this code. So see here they have been calculated the parity. Okay, so the parity bit here is 0, because here we have, so here we have 4 number of ones, so the parity is 0 because we are considering even parity. Here also we have 4 number of ones, so here also 0. Here also we have 4 number of ones, so here also our parity is 0. Okay, so that's how we can also implement our parity, even parity calculator. Okay, so we have already seen that, like how your functions is being called and how your function is being defined. So see, the main intention here was not to see the logic of function. Our intention was to see how your function and task has been executed. So here in function we haven't included any time delay. If we are doing so, so it will throw an error. Okay, now let's see the pass by value and pass by reference, so that will give you a more clear understanding about them. So this is the example of our pass by value and pass by reference. So first of all, here we are passing our value as in pass by value. Okay, so you can see that here we are not adding any kind of reference. Whenever you are using ref keyword, so that's considered under the pass by reference category. So here we are giving some pass by value and we are performing some operation. So here we are getting some value and then we are multiply it with 2. Okay, and then we are printing that value. Now as pass by reference, here also we are getting some value and then we are using some operation, we are performing some operation and then we are returning that value. Okay, so that's, so here we are getting some value and performing some operation inside the with the values. Okay, so here in above we are sending as an pass by value and the below we are sending as an pass by reference. So I have called my scalar 5 So I have declared my scalar 5 and my dynamic array 1, 2, 3. Okay. Now I have initialized this with some value, and then I have called my task like and after that I have called my task which one modified value by value and the another one modified array by reference. So here you can see I have called my task modified value by value and I have given value 5 inside as an argument, and here I have called my modify array by reference, and here I am giving my dynamic array, that is 1, 2, 3. Now let's see the result. So here you can see I have passed a pass and the task value inside the value in 10. Okay, passed 5. Now after performing operation, which means 5 into 2, we are returning 10. Okay, so here we are getting 10 after task my scalar 5, because see after task we have seen like we have called here after task and that remains 5. That means your original copy doesn't get any changes, or your changes doesn't get reflected in your original copy, and that's happen in your pass by value, because for each call separate copy has been created, so your original value will not get override. Okay, so this all happen in pass by value. Now let's see in pass by reference. So I have initially passed 1 to 3 as my array. Now we are taking inside original array 1, 2, 3. So see here initially our array was 1, 2, 3. Now we have passed. So see initially our array was 1, 2, 3 which we have passed. Now after operation here we have performing one operation. So 1 plus 10 11 and 2 plus 10 12. So we are getting 11 12 30. Now after calling from its module we get changes. Okay, so here we can able to see changes in the original variable. So the conclusion is that you can able to see the changes in your original variable also whenever you are passing your value as an pass by reference, but you can't able to see the changes whenever you are passing value as a pass by value. Okay, so this is the conclusion. You can also refer this code. I will send this code link, so you can also refer this code and try to execute and understand this in clear way. Now let's see the application of constant. So see here I have declared one module and I have considered one constant function. So here you can see that our int array is constant. Okay, so we have implemented some constant kind of thing, constant function. Now let's run this code and see the actual output. It will be more clear from the output itself. So see here initially we have passed 10, 20, 30, 40, 50. Okay, so the sum of the element which we are printing in here in the function, so the sum of the element is 150. Now our array after function call. So here you can see here after function call, like we have declared this thing, and after function call our value will remain as it is. Like after function call your array will remain as it is, 10, 20, 30, 40, 50, like you're unchanged as expected, because it will not change because you have declared constant variable. Okay, so your values will not get affected by this. So I have covered all this in detail. I have also taken some examples to get you clear on this. Now this is all for our today video. So if you found this video useful, you can like this video and comment your thoughts, and also subscribe this channel to be a part of 100 Day System Verilog challenge, and we will meet in another video. So thank you.